Good day and welcome to HVAC 350. My name is Joe Pacella, Associate Professor here at Ferris State. The purpose of this lecture is really a re-recording of a chat, and I'm going to try to do the best I can with it. We had about a two and a half hour on the high side chat yesterday on the remaining part of the Granite and Gables building. And it kind of goes similar to the lectures that you've seen in the class already, but I had students asking me questions. So what I'm going to do is I've got on my monitors, I've got one monitor which I'm actually going to say people's names that were asking questions and try to answer those questions, just because yesterday's chat I thought went real well for the guys that attended it, and I just wanted to have this available for you. I don't know how long this is going to end up being, and we'll just kind of go from there. All right. So the purpose of this chat was to go through the remainder of the building, which is not floors 7 through 19. It was the rest of the building. So what we're going to do is the first thing we had is we had different questions on different parts of the building itself. And again, I did lose some of the information on the chat, so I'm missing some of the beginning of the chat session. But I'm going to give you, my take on what we went through yesterday. First of all, in the building, we're going to be looking at in the building floors the MB 101 through the MB. We're going to go through the 6.01 drawing. So. We're not doing any of the garage. I'm giving you that as a subcontractor coming out in the next assignment that you're going to be doing. So what I wanted to do specifically, and a couple of guys were asking questions about how to do the risers again, and we went through that. We'll do the same thing here. We did it actually twice. You should have a lecture that's available. We did it at the end there. Juan showed up a little bit late, and we went through it the second time, which was all right. And I'll probably do the same thing again just to make sure that you guys have that. First of all, starting on the first print here, there's some items in here, and I was talking to the guys yesterday. If we look at this part of the building right here, and this ductwork that I'm pointing to right here does not have any size on it, neither does this takeoff here. What I would do with this is I would go ahead and use the same size duct as here, either 12 by 12 or 12 by 14 duct for right now. It's going to be a small part of the building, and I would make a note that says something like sizing is not provided. Trying to get in here to edit it. Verify prior to fabrication. Now the reason I would recommend you do this, and this is a lot nicer, the software that we have here compared to when I was working, and what I mean by that is we can make a note on here. I mean, the person that's going ahead and doing the estimate right off the bat, we always end up doing some type of engineering as we're going through this. And we've already identified some items, so if the company were to get this project awarded to them, and when this gets handed over to the project manager, every time you have a call out like this, it makes it easy for them because they know that there's something they have to do, and it will make their job a lot easier. So where do we do the call outs at? Right up here. It's a thing called a call out. You click on that, and you just click on it, and you can put one in, and you can put some notes in it. What's nice about this is you can go ahead and once you have it completed, what I would do is I would move this out of the way so it's not over any part that's colored or taken off, and then I would point to what I'm trying to do, and I just grab the end of that to point it there. And that makes it a lot easier for me, especially because, I'll understand there's some items that are not well defined. And by the way, if you've done any work at all in our industry, you'll know that sets of prints are never complete 100%. There's always errors with them, and it's just what we have to deal with. So this is an easy way for us to deal with it. Do a call out on it. That way everyone would be aware of it. Now, other than that, on this part of the building here, it was pretty simple to do. Not too much with it that was difficult. Again, be careful. Try to stop at a match line between this drawing and the next one, which happens to be the B drawing, I believe. We'll get to that in just a minute. You can see we've got a toilet exhaust fan here with some 12 by 12 duct that's going up into this area. And you can see we've got some transfer grills here. Now, it's kind of different. What I found very strange about this, you can see there's a register here, here's another register here. So what they're doing is, I want to zoom in on this a little bit. Pretty straightforward. A bathroom is going to be at a negative pressure to the hallway right next to it. So here's the hallway right here. So we're going to be putting in less supply air via this register. then we are going to be exhausting out via this register right here. So that being the case, what we end up doing is we take air from the hallway via a transfer duct, excuse me, and you can see we have a register here and a register here. This is going to end up being flex here. And because that's 300 CFM, it doesn't say this, but it's probably going to be 10-inch duct. So this will probably be a piece of 6-foot 10-inch flex right there. So that's one of the things that's not listed out real well, and that would be another item that you could put a call out on. And again, doing a call out on that would be as simple as doing something like this. And once you get that done, again, you can see how it kind of gets in the way. Just move that up out of the way, grab this tail right here, and point to it there. And that's something that you could use to make it a little bit easier on you and then for the person that would actually be project managing if they get the project. Now, if there was a lot of items that were really in trouble or real in bad shape, then you would definitely want to contact the engineer and do a request for information so you could kind of get the answers for that if it was a lot of items on a project. If it was something that was happening on every VAV box, for example, that could be quite costly. On this here, it's not really that much. And if you were to lose the project based on the size of this ductwork right here on this one section and these right here, it would, of course, it would incense you, but I doubt that would happen. So as we come across here, I had someone ask a question here. Now, when you look at this, it says 2 10-foot J slots with 4 8-inch 4-foot long plenum. Now, what this means is, if you look, there's a slot here. If I were to do a measure across here, hopefully this is about 10 feet. So you can see that's just about 10 feet right there. And you can see I already did that before. Did that yesterday during the chat session. So this is a 10-foot piece. That's all they want is a continuous slot here and a continuous slot here. That's the second one there when it says 2 of them. And we have 4 registers. I only want you guys to count the registers with this here. So there'd be 4 registers. And again, notice how from the prior or from this right here, you can see that this is right here. That's flex there, and that's flex there. And what I would expect is there'd be a 6 foot of flex, and we'd have, in this case here, it's going to be 8-inch. So we'd have an 8-inch takeoff here, an 8-inch damper, some 8-inch pipe. We'd stop and go to a 6 foot of 8-inch flex. So they showed flex in 2 different ways. You know, my take on it, like I was telling the guys yesterday, it's probably just a different engineer that did the job. And so I just wanted to make sure we covered that yesterday, or from yesterday, excuse me. In addition, as we went over to here, there wasn't anything that was very difficult with this, other than when we get to the floor above this, we'll look in here, we'll see where this supply comes from above, from the floor above, from above, from a variable air volume box. So we'll get to that here in just a minute. And you can see that the thermostat here goes to that box. So that was pretty much all we had on this print here. And this happens to be the end of the print. This is that Toyota exhaust fan that was coming up. So a lot of times I would have stopped with this at this match line right here. And on the other print, I would have taken it to here. And then on this print, I would have gone up like this. That's 12 by 12 rectangular duct. This duct would not have to be insulated. And here we'd have a register box or a louver box. If you were to look at this M1 note, it says something like have a 4 square foot opening. So what I did with this, I'm going to go to pointer mode and click on this louver that I've already taken off. This louver happens to be a 24 by 24 or 2 by 2 or 4 square foot. We have a 24 by 24 motorized damper, and we also have a 24 by 24 louver box. And I know they're not put into place real well. This was a leftover from yesterday. I just went and threw them on there just to make sure that we had them covered to show you guys how to do those. All right, I'm just going to keep going here. I'm just keep looking at the notes from the chat. All right, this is the next floor here. This one's a little bit different. What I mean by that is you can see in here, and be careful of this here, there's going to be a MB301 diagram 4 takes care of this area. So make sure you look at that. So you can see that we have some transfer duct that goes into there, so you might want to go right to the wall with this if I was taking this off. So I would do something like, let me collapse these and go to our transfer duct. And we'll go to the 72 by 22 and just take that in. So I would do probably something like that into a wall where I could, when I go to and do this detail here, we can do that better. So in here we can see we got some ductwork coming out here. That goes to a VAV box, which is located in this room. And you can see in here that we've got some supply air and we have some supply air again. Now this is very strange when we look at this. I mean, none of this seems to line up real well. Welcome to, estimating. The engineers sometimes do a great job, sometimes they don't do a very good job with this. If I were to look at this, that's 40 by 22 duct, and that happens to be insulated but not line duct. So if I did 40 by 22 duct here, I could come across, and you can see that it really doesn't fit real well there, but I took that duct off. Now if I go to pointer mode, spacebar, and then I grab this, you'll see how that fits real well in this other duct down below here. So what's going on is this ductwork doesn't actually run here, it runs down here. And as a matter of fact, when you look at the diagram for here, it ends up running, I believe, to this small unit right here. There's 2 units in this room, and we'll see that in a future slide. So you'll want to take that off, and I would just, with the way this is laid out, I would leave these boxes just how they are. This first box here is a E1750. I can't remember the size of those. It might be a 14-inch. I don't recall off the top of my head. The way I'd find that is go to the 6.1 drawing. But make sure you do a takeoff and a 90 on this. We'd have some flex, a 2-foot piece of flex here, and then coming into there, we would have that. So I would just leave these just the way they are here. I know and you know that actually this is going to end up scooting over, and it's going to be coming out of this duct. And actually it's probably going to be off of this 90 just a little bit further too, instead of right at that 90 there. But it's unclear 100% where the engineer was putting this ductwork here, this 40 by 22 duct. I see it going right here. I don't know why, again, they didn't put everything based on that. So one of the things I mentioned a couple minutes ago is we had some ductwork that went down. This went on the other print here, and you can see this comes from this VAV box right here. And you can see that this VAV box, we've got our 2-foot connector, we've got our other duct connector on this side here. It doesn't tell us what size duct. I think 16 by 12 might work for that based on the CFM of it. And you can see there's a register here, and then we've got this ductwork that goes down. And I believe that the thermostat for this box actually was on the other floor also. So within here, again, you'll see that this is our flex, just done a little bit differently. We can't worry about it. That's just the way it is. So when we come across here, we'd have, I would still put a damper, although it's kind of hard to see that. We can zoom in a little bit. You can see that they still have a damper there. It's very hard to see. So we'll have a takeoff and a damper and some flex on this and a register and call that part done. We are going to talk, we're going to be getting to the riser here shortly. Let's just kind of keep moving through the building. Okay, this part is completed. I'm going to kind of sift through these relatively quickly, and we're going to get to the MB3 drawings. And this is the first one here. Now, when I was talking with the guys yesterday, and this might have been caught on the end of yesterday's chat, again, was this part of the building here is the core of the building, and it takes care of more than one floor. If you look at floor 7 is a little bit different than the rest of them. Floor 7 has some ductwork that comes up here, and it has some ductwork here. So what I would tend to do is I would go into the cover sheet, I would duplicate that print, and I would have one of them for floor 7. Then I'd have a typical probably 8 through 19, and kind of go from there. Now if we look at this, this is going to be duplicated many times. So if I had one just for floor 7, I might take this off on just the floor 7, this one also, and you could do this one also because this is a partial plan penthouse. So let's kind of zoom in a little bit and talk about these areas now that I've talked about them a little bit. We'll kind of cover some areas that were asked yesterday by various people, and I'll try to cover those in detail for you. First of all, there's a light cove here. Now when you see this here, it talks about an M11 call out. You can go down and look at those, and you can see there's only a few of them in the building. So there's one here, There's one here, and I believe I saw one on another print somewhere else. There's not too many of these, and really what they're talking about here, and this is just showing flex. And if you go, you can see some 10 by 12 duct, which is right here, that goes to a connector, and where we attach this like this. Not too many of those, pretty strange to do that. And also when we come into here, you'll see that there's one here again, you'll see that there's one here, and the rest of this is fairly straightforward, other than it talks about, like right here, 12-inch next to a C register. This is on some exhaust duct, so if I follow this backwards, it's going to go like this. So you can see this is 12-inch duct. So what I would do is I would run 12-inch duct with a volume damper there and a takeoff off of this main duct here. I'd run it across, put a 90 there, and I put a 90 here also. It looks like that's all. This is probably a hard ceiling, and there's no flex above here, so everything's going to be hard connected. So I would just put a 90 on that and attach that register, that NKC register there. And you can see there's some of those there. I had a question yesterday about this part right here, and it's going to be answered pretty much the same way. We've got this 12 by 12 duct here, and you can see that this goes to this duct right here, this 8 by 14 duct. And if we come to the top here, should be able to find that right here. That goes to toilet exhaust duct just for floor 7. Let's go back over to that area. And you should be able to see in here, oh, blew by that a little bit. It's going to be 12 by 12 duct here, and there's 10 by 10 takeoff on this, and then there's going to be some D registers at 215 CFM apiece. We're not going to be able to do too much with this. If you think about it, there's probably going to be a small drop, maybe a foot on the high side with that, and then go right to the register. There's not too much we can do. It's not detailed anywhere. Kind of difficult to take off, a little bit anyway. So you may have to add a little bit of ductwork there for that. I'm going to go back up into this room right here and work on this before we get into the roof of the building, because we're going to be on that for a little while talking. This here is the 7th floor. This happens to be another area here where they have a lot of bathrooms here. And you can see in here we have, again, we're going to have some exhaust. The exhaust does not have to be insulated. And as we come across here, we would have, in this case here, we'd have, these are all 185 CFM a piece. Each one of these I'd run an 8-inch out to it because it doesn't say it there. So I'd have a takeoff and run some 8-inch duct in a 90 and put the register there. Now you can see right here that this is our chase that goes up for our toilet exhaust fan. And just keep that in mind. We're going to get there in just a few minutes. And you can see the fire and smoke dampers that are here. And we just want to be careful. We only count those one time, and we'll talk about that shortly. As we come across, this is our mechanical room. Our mechanical rooms, you'll see that all of them have a small exhaust fan. Floor 1 and 2, it's a little bit different the way it's laid out. It actually blows the air this way into the mechanical room. But there's a fan here. There is a small audio-visual room where they have some servers and some other electronic information, electrical equipment in here. And that's all it does is it sucks the air out of here, goes through an E register, 24 by 10, and blows it into the area outside of the room there. It gets caught back to the unit, goes through the duct silencer here. I mean, it goes through the duct silencer, the transfer duct, ends up in the mechanical room. In here also, we've got a unit. We've got some ductwork. It calls for the first 20 feet of this ductwork to be lined. So we're going to say that any of the ductwork, when it comes out to where it splits off, that's the only duct we're going to have lined, and I'll show you that on another print here shortly. In addition, this is our chase for our fresh air duct. So this is coming down from above, and there's some ductwork that goes horizontally here. Another fire and smoke damper, and it doesn't show this on here, and I'll show you where it does in a future drawing on the next print 302. This is actually a VAV box, and I'll show you those in just a couple minutes. Staying on this drawing before we go into the MB 302 print, this is the outside air duct chase, which is the same chase as this right here. And this is a penthouse drawing here. We got some air conditioning units that cool the penthouse up there. And you can see here, this happens to be our toilet exhaust fan. This exhaust fan goes horizontal, and then it blows air out, so it's sucking air up through this shaft here. So anything that's horizontal, we're going to take off on this print. Anything that's vertical, we're going to do on the riser. So what I would expect you guys to do is to take this ductwork off horizontally here and going out that way. Please don't take any of this off. This is all piping for the cooling towers. We're not going to be doing that at all. Piping should be handled as a subcontract. And in addition to that, whoops, let me get over here. You'll also see that there is a louver and a backdraft damper. And this is shown a couple different places, so let's make sure we only count it one time. And I'll show you that here on the riser diagram. Right now, let's go to the MB302 print. Now 302 is, I've got a couple of call outs we were messing around with yesterday. Let me delete these real quick. Now this happens to be, oh, this is the same print. Let me go to the next one. There we go. Sorry about that. This happens to be the level 2 floor plan for the mechanical room. I'm going to zoom in on this a little bit and talk about this so we can kind of get a feel for it. This gets a little confusing because you got ductwork going underneath each other, and this is pretty typical for mechanical rooms. The nice thing that would have happened is if they would have done an isometric view or a side view of this unit, which really most of the time engineers do that so we can see what they're talking about. Now I can see this only because I've done this for probably too long professionally, but again, you can see we'd have this same ductwork we talked about before, 72 by 22 transfer duct. So you can see we would take some of that off and maybe go to one of these walls on the other print and this one just to make sure we've got that taken care of. You can see we've got some 12 by 12 duct going down. On the diagram below us, you'll see it probably goes to a VAV box. You can see this large duct that comes out of here comes from this self-contained unit, this 01B. And this other 01A has supply duct where this X is at, and it comes across. So both of these are supply ducts. This is our outside air coming in, and check this out. We've got our outside air coming in. It drops down, so it goes down below, and it comes across, and it goes to a G VAV box. So that's a 4400 CFM box. And then that comes across here, and it goes down to the unit. We were talking yesterday, nowhere in here did they go about putting in the return air ductwork to the unit, or for that matter, they don't put the supply duct that drops down. They don't show the size of the connections. If you look at it right here, this is our unit right here with the diagonal dash marks in it. That's going to be supplying air up. It's going to hit, we don't know how far it's going to go up, and then it's going to hit this ductwork and go out. And then there's return air ductwork that goes down on this side of the unit, and that's not shown at all. And we're not even including that in the price of our units. For this project right now. We have no way to look at it, so I'm just going to not include that with our price for that. So just keep in mind we have a couple pieces of duct that aren't shown on the print that we need to take care of, or that we would have to take care of when the project came in. You can see here we have some more duct work here. Make sure you look at M3 here. This is some more transfer duct that will allow air to come from here into our room here. Now as I go down, you can see a better look. This is that ductwork that it shows 28 by 28 duct going up, and it shows 24 by 24 duct going up that hits that ductwork that's going horizontally. If you remember, that one duct came across like this, and the other one came across here, if we look at them, like this. So this is the 28 by 28, 24 by 24. We just don't know the height of that, and it's not that much of a cost for the project, but realistically, we would want to have that if we had that information available for us. You can see this return air right here. There's going to be a 38 by 18 outside air up. And if we looked at this, this happens to be 30 by 18 right here. And that goes down. So that down is going to hit this here. And that's going to come from this VAV box right here. You'll also see on this one, I'll zoom in a little bit more, that we've got a C box here. This was the outside air coming down. It goes through a VAV box and it goes down into the return of the unit. Now they put VAV boxes on this job strictly because they wanted to have an accurate record of how much outside air was being brought in for ventilation. Every VAV box has an analog input on the control side that could read flow, and they'll be able to document the type of, or the amount of CFM, and they'll be able to control the amount of CFM. There's all kinds of control strategies out there. If you happen to know based on CO2 levels in the space. You might be able to bring in a less amount of CFM, or if we have a good way of determining occupancy, you can go ahead and bring in less outside air if the space is not being occupied, or if it's just being tenant overridden for a weekend. All kinds of different control strategies we can do. And this is the only one where we talked about taking some air out of here, and it's going to exhaust it into this room, or it's going to be grabbed by this unit, be reconditioned, and go up. So this is one of the exhaust fans that's there. So there'll only be one copy of this here, and so far we've got these two areas. And then coming over here a little bit more, we've got floor 7, and floor 7 has this talks about strictly here the ductwork for cooling of the elevator lobby. So make sure you have that taken care of on that floor. And you'll notice that if you look at the scale on this, and if I use the scale finder here, I can come across here, and that looks pretty much that that's 4 feet. Well, if we come down to this last one here, this last part of this drawing, this is a partial, it's a level 6. And if I go ahead and take this across, this comes in at 4 feet, but it's actually 8 feet. That means anything that I go ahead and color or take off on this is not going to be correct. This happens to be for the exhaust fan number 2, toilet exhaust fan. This tells me, because the scale's not the same, I have to go to the cover sheet. I have to find that unit, that drawing, MB302. And I've already done this where I've copied it. And you can see here there's a scale on one of them that's 1/4 inch per foot. The other one is 1/8 of an inch per foot. So if I cancel out of this, come across here, you'll see that I have 1/8 of an inch equals a foot on this one. And you can see that I already did this. I did this yesterday, where I went ahead and tested that to see if that's right. So now I know that I only will color this diagram here, or take off this diagram, and it will be correct horizontally. Now, with that being said, I wanted to show you why we want to do all the horizontal ductwork on these prints and the vertical ductwork on the riser. So the riser print is the MB401 print, and this is it right here. Now, the fan we were just looking at, you can see toilet exhaust fan number 1 is on the roof. We were just looking at toilet exhaust fan number 2. Now, this is it right here. Now, this is our horizontal duct here, and we have our vertical duct here. Now, I'm going to go back to that other print. And you can see this is actually where the fan is, and this is the exhaust duct coming off of that. So we want to just do all of anything that's going horizontal, we want to do it on these plan view drawings and not the riser diagram. We're going to use the riser diagram really just to grab the duct that's going vertically. Hopefully that makes sense to you. As we come across here, I'm going to start on the left side. Don't worry about anything on this part here. This happens to be condenser water piping, so Control Z there. All of this here, let's try this 3rd time, see if we can make this work now. There we go. All of this here is going to be done, it's going to be treated as a subcontract, that we will be treating this as a subcontract in the bid. So don't worry about any of this stuff right here. About the only thing you might want to use this for, you could count the units here if you wanted to. This happens to be our outside air fan. So again, this is going to go horizontally, and we're going to get to another drawing here shortly where we go through this. But the horizontal part we don't want to do on this drawing, we only want to do the vertical. And this is why. First of all, this print, when I go to the bottom of it, it is not to scale. So how do we deal with this? You know, we've got some things here, some levels drawn in here. Most of these look like they're pretty parallel, they're pretty equidistant. Some of these are a little bit closer as you go down. They're not as widely spaced. This drawing was meant to be shown as an isometric, not as a true like a height drawing. So typically I'd go to the architectural prints, which we do not have. So because I don't have those, we're going to use these, and the way we're going to use them is go to the MB501 drawing, the MB502 drawing, and here we can see that the space between the floors is 14.6. So if I'm going to look at it that way, I can come back to the other print, the riser print, and I want to make the distance between here and here 14.6. And in another lecture, I showed you how to do this. We'll do a calculate scale. We'll do 1406, 14 foot 6 inches. We'll zoom in, and we will go ahead and do the best I can with this. And you can move it around a little bit till you get it where you want. And if you're happy with that and hit OK, you've just set this drawing, and it ends up 1 inch is 16 feet. So it's roughly that now. So if I were to go ahead and do a measurement, hopefully it'll be like 14.6 between this floor, if I did my job right. Well, kind of. So I think you guys get the understand what I'm saying there. So that being said, you see this ductwork coming here. Now here is an exhaust fan with ductwork going up. Now, not everyone has seen projects get installed, but if I go right to here, that's showing like a 5-foot drop that goes through. It's showing like an 8-foot piece of duct that goes here. That might be a little bit excessive as far as the height off from the floor to the fan. It probably is going to be. So what I try to tell you guys to do with this here, because we don't have a good drawing with this, is I'd put this a couple of feet, maybe 3 feet on the high side above the roof here to take care of the vertical drop part of it, and then just run it down to the duct like this. Anything horizontal, do on the other print, and you'll be okay with it. You'll see we've got a fire and smoke damper, and we've got 1200 CFM going to every floor. I think other than 7 has got that extra bathroom in it. So by the time we get to 7, this is it right here where it's got 1200 plus it's got another 1750 on there. You can see there's 2 fire and smoke dampers there. And then there's this exhaust fan too that goes down here. So if I go back to the floor plan real quick, you can see in here, this note says 7th floor only. There you can see there's a fire and smoke damper there. There's a fire and smoke damper here. This is our chase. And we'd have that ductwork connect for floor 7 on both of those. Floor 7 through 19 goes just this one here. So that should make sense to you. So back to our riser diagram, what I'd just ask you to be careful on as you're doing this is that this fire and smoke damper is shown in 2 different locations. Make sure you count it 1 time. As I continue to go to the right, you can see this happens to be the stairwell pressurization fans. There's 2 of them on this building. Their job is really to try to lower the stack effect that's happening with the building by preventing, by pressurizing the stairwells and not letting them act as a chimney inside of the building to as a conduit for air to go from the lower floor up, or on super hot days from the upper floor down, as the cold air will fall. So as we go ahead and look at this, we have some horizontal duct. It's going to come down through the roof, and there's no ductwork here like it shows over here. That's because this is just a chase, which is just an opening. It's going to be contiguous all the way to the bottom of the building. They're going to have holes cut into it that are 24 by 24. They're going to have a volume damper for air balancing and a register on them. So what's going to happen is the air balancer is probably going to have these more closed, and as you go down the building, they're going to open up more, and it's going to be designed to maintain the pressurization in that stairwell to try to lessen the amount of infiltration that's happening in the building. And you'll see that's going to happen on both of these units here. And I want to specifically go to this drawing right here. This is MB 105A. Now this one here shows our roof plan. Again, we were just looking at this area right here, which happens to be the chase for stairwell pressurization fan number 2. You can see they don't show any duct. They have an X, or it's just a chase. There's no ductwork. And then you'll see on in the penthouse, there's going to be a louver here and and please reference this MB 30101 with that also. Again, don't do anything with the cooling towers. Don't do anything with this piping. Make sure you don't do that. This ductwork here is a little bit, doesn't show this size here. I would take this 96 by 20, just run it to here. This ends up, it looks like it's about 36-inch round ductwork here. If you can take a little piece of 36 and put a 90 there. This part here is not very well defined anywhere. By putting some extra 96 by 20, it's going to cover the cost of that part of it there. When we get into here, we can see there's a couple of condensing units that go into the penthouse. We saw that on the other print. I believe it was on the MB301 print, the bottom right, that detail there. And here we can see, when I zoom into here, you can see we've got a motorized damper to allow air coming into here. And you can see here we've got an M1, and I would definitely make sure you take a look at those. There's two 22 by 22 eye registers, and you might want to just count those across like that. This exhaust fan too is going to be blowing, sucking air out of here, going through the exhaust fan, through the motorized damper, and out here. In addition, this gets people a little bit. You can see here, this is our horizontal ductwork for the toilet exhaust fan. Toilet exhaust, excuse me, I said the wrong thing. Outside air fan, sorry about that. That outside air fan is going to be pulling air through this louver. It's going to come into the fan, it's going to go horizontal and go across and go down. I would take this 48 by 64 outside air, I would just take it all the way across. And you're going to use this right now. I would take this all the way across here. As it's going to turn and go down, make sure you have the damper either counted here or on the riser diagram. When we look at stairwell pressurization fan number 1, it's got some ductwork here, 66 by 26 duct right here. Now this ductwork coming this way is the same size, and they just flipped it and it's on the edge of it instead of being on the flat end of it. So we're going to run the same size duct this way. When we do that, it's obviously not going to fit in there like we've seen it in the past, so don't worry about that, but we use the same size duct into this here. And you should have one relief hood in the system also, or in the conditions also. So let me see here. On this print here, that's pretty much it. Just a few items with that. I'm going to pause this for just a minute. I want to look at the notes and make sure I didn't miss anything else from our chat. I'll be right back with you. Okay, that being said, I just kind of looked back at the chat log. There was a couple of minor items that only a couple people had on there that I could see. Most of the people were trying to make sure they understood how the riser would fit. And really the reason that we do this building, guys, I know this building's a little bit big, but it kind of gives you you have to think about how ductwork goes through a building, both in a vertical and horizontal method. It's not a perfect building by any stretch of the imagination, and every time you do an estimate, there's nothing real perfect or pretty about them for the most part anyway. So what I'm going to do is I'm going to call this, I'm going to stop this lecture right now. I'm going to go ahead and post it out, and then I'm going to call for another chat session on Tuesday. That would be the 22nd. That was the day that this was due. I moved it to the 24th. So with that, please bring your questions with that. You're also going to notice that for spring of 2016, I'm also going to be opening up our second exam on Wednesday, and on Tuesday on our chat session, I'll also have a review on the exam. So thank you very much and have a great day.